Okay, let's begin taking a look at what is called a mole. Okay, so what is a mole? Now, in chemistry, a mole is a count. As I've defined here, it's a fixed unit used to count atoms, molecules, particles, formula units. Okay, it's how we count stuff. Okay, so just like when you go to the grocery store and you buy a dozen of eggs, you automatically know that there's 12 eggs in the carton because it's called a dozen. When you work chemistry and you hear the phrase, you have a mole of a substance, then you have this many, 6.022 times 10 to the 23rd pieces of it. Okay, so if we're counting atoms of gold, a mole would be this many gold atoms. Or if we have water molecules and we have 1 mole of water molecules, it's this many water molecules. Okay, formula units, just think of them as molecules, only it's an ionic compound. Instead of a molecular compound, they just use a different term for it. Okay, so a mole is a fixed unit to count in chemistry. Okay, it's named after Avogadro. Sometimes it's called Avogadro's number. The mole is Avogadro's number. Okay, because he's the mathematician, scientist that worked to develop and to derive this number. Okay, so let's review. 1 mole of any substance, okay, whether it be an element, a compound, a molecule of oxygen, 1 mole is this many, 6.022 times 10 to the 23rd pieces. Okay. Now, how heavy is it? So, could you pick it up and carry it? Or would you need a dump truck or a forklift to pick up that mole? Because 6.022 times 10 to the 23rd, that's a lot of pieces. Remember that 10 to the 9th is a billion, 10 to the 6th is a million, so this is 10 to the 23rd. This is much larger. Okay, so 1 mole of any substance is Avogadro's number of particles or molecules or atoms, and how heavy it is in grams is equal to its mass number. Now, where does the mass number come from? The periodic table. Okay. Let's look at this first sample. 1 mole of aluminum. So think of a soda pop can or maybe aluminum foil that you use in the kitchen. 1 mole of aluminum is equal to 6.022 times 10 to the 23rd aluminum particles. So little bitty atoms of aluminum. 1 mole is 6.022 times 10 to the 23rd. How heavy is that? 26.9815 grams. Where did that number come from? How did we know that was the mass of 1 mole of aluminum? We go to our periodic table. Okay, now this is a photocopy of a periodic table out of one of my several reference books. And see aluminum. The 13 is the atomic number. That tells you the protons and the electrons. This 26.9815 is the mass number, or you notice on this periodic table they call it the atomic weight. Okay, tells you how heavy it is. How heavy it is. Okay, so 26.9815 grams of aluminum is 1 mole. If we look at it in terms of water molecules, 1 mole of water contains 2 moles of hydrogen. Okay, you see, because there's 2 hydrogens, and 1 mole of oxygen atoms. Okay, see, we put these atoms together to make the water. So when we have 1 mole of water, that means we had to use 2 moles of hydrogen and 1 mole of oxygen, put it together. Okay? That's what I've shown you here. See, 2 times Avogadro's number will tell you how many hydrogen atoms you have total, and then 1 mole of oxygen, so the 6.022 times 10 to the 23rd oxygen atoms. How heavy is that? It's not very heavy at all. 1 mole of water contains 2.016 grams of hydrogen and 15.999 grams of oxygen. Where did those numbers come from? Our periodic table. Hydrogen is 1.008 grams is its mass, what we call the molar mass, the mass of a mole. We've got 2 of them, so we took 2 of these, and we took 1 of the oxygen's molar mass, its weight, its mass number. We add those up. So 1 mole of water would have a molar mass, okay, so that's the mass of 1 mole of only a little more than 18 grams. Okay, not heavy at all. Not heavy at all. See, so 1 mole of water, this compound, is not even as heavy as 1 mole of aluminum. Okay, because remember, all of the molecules, all of the atoms, they are going to have different masses because they have different number of protons, electrons, neutrons in those atoms, so they're going to have different weights. Okay, no different than 1 mole of donuts, 1 mole of eggs. They would both be 6.022 times 10 to the 23rd, but they obviously would have different weights. Okay, you go to the grocery store, you buy a dozen eggs and a dozen donuts, you get 12 of each, but they obviously weigh different. They're made out of different substances, different sizes, and so forth. Okay, so let's practice with some of these. Okay, so here again is the same information about what is a mole and Avogadro's number. Okay, and do not feel obligated to memorize it. You can always put it into your calculator. Okay, so let's try some of these. What is the mass of 2.2 sulfur moles? Okay, so we have 2.2 moles of sulfur. Okay. How heavy is a mole of sulfur? We go to our periodic table. Sulfur is right here. It has a mass of 32.06. Okay, so 32.06 grams of sulfur is equal to 1 mole of sulfur. Okay, so I'm setting up a little conversion factor. Some people call this dimensional analysis. Okay, so I'll multiply 2.2 by 32.06 because each mole of sulfur is 32.06 grams. So I got 32.06 times 2 comes out to be 70.532 grams of sulfur. If I'm practicing with my sig figs here, I have 2 sig figs in 2.2, so this would get rounded up to 71 grams of sulfur. Practice with our sig figs. Okay? And then how many atoms of sulfur is that? Well, 2.2 moles of sulfur. We're going to use Avogadro's number. 1 mole of sulfur has 6.022 times 10 to the 23rd sulfur atoms. Okay. Just like if you were going to go into the grocery store and buy 2 dozen donuts, you would get 12 and 12, so you'd get 24. Here, every time we get a mole, we get 6.022 times 10 to the 23rd. Quite a few more. Okay, so let's see what that comes up to. Put this into our calculator. Let's see. my calculator is not wanting to calculate. Let's see, 2.2 times 6.022 times 10 raised to the 23rd, and let's see if my calculator now is working. No, it is not working. Okay, well, we will do it the old-fashioned way. Okay, here we go. We got it 1.32484 times 10 to the 24th. Okay, so what we've got now, if we're practicing with our sig figs, we're going to get 1.3 times 10 to the 24th sulfur atoms. And then let's say, well, how heavy is the mass of 2.2 moles of sulfur dioxide? Okay, so last week we practiced with naming formulas and compounds. Sulfur dioxide, 2 oxygen. Okay, so there's sulfur dioxide, 2 oxygens with the 1 sulfur. We have 2.2 moles of those. Okay, so 1 mole of sulfur dioxide. Okay, how heavy is sulfur dioxide? What is its molar mass? We need to go to our periodic table. Let's get 1 sulfur, because we have sulfur dioxide. So I'll write it down here for you. Sulfur is 32.066. Then we're going to get oxygen, which is right here, 15.999. But we're going to need 2 of those. Okay, we're going to need 2 of those. So we're going to have, because it's dioxide. Okay. So we're going to add these together. And we get 64.06 grams sulfur dioxide. Okay, this is what we call the molar mass. See, a mole is 1 sulfur and 2 oxygens. So we take their mass numbers and we add them up so we can see how much that weighs. Okay, so 64.06 grams of sulfur dioxide is 1 mole, and we have 2.2 of those. Okay, so let's go 2.2 times 64.06. And if we practice with their sig figs, it's a little unusual on this one because the calculator says 140.932 grams of sulfur dioxide. If we round that to 2 sig figs, it ends up just being 140 grams of sulfur dioxide. Okay. Now let's try this last one. 2.2 moles of sulfur dioxide. How many sulfur atoms are in there? Okay, well, 1 mole of sulfur dioxide is made up of 1 mole of sulfur and it has 6.022 times 10 to the 23rd atoms of sulfur for 1 mole of sulfur. Okay, see, so we're taking it apart and looking at it individually. Okay, so well, look at this. We go 2.2 times 1 times Avogadro's number, and then we divide by 1 times 1, which is just 1. So that comes out to be 1.3 times 10 to the 24th sulfur atoms. What about oxygen atoms? How many oxygen atoms would we have? Well, with oxygen, all we would want to do is look at its piece of sulfur dioxide. So for oxygen, we know that we have 2 moles of oxygen, because dioxide, 2 oxygen, 2 moles of oxygen in each one of the SO2s, and 1 mole of oxygen is still 6.022 times 10 to the 23rd atoms of oxygen. So we go 2.2 times 2 times Avogadro's number, again divide by 1, and we get 2.6 times 10 to the 24th oxygen atoms. Okay, so Avogadro's number is a great constant because it helps us count atoms, and it helps us take those counts and determine the mass. How heavy is it? Are you able to pick it up? Are you able to carry it? Sure you can. 71 grams of sulfur, you can carry that in the palm of your hand. Sulfur dioxide, 2.2 moles, right at 140 grams. Okay, not even half a pound, just a few ounces. So not heavy at all. Okay. So again, a mole is a way to count atoms or count molecules, and then we can take that count and we can convert it to grams, so we know how heavy it is by using the mass numbers from the periodic table, which we often call molar masses.